multivariable system of equation. We have one system with three unknowns, x, y, and z, three equations. So the first thing that you do is you number each equation, 1, 2, and 3. If you don't do this, your work will be very messy when you review your work. So I have negative 5x plus 2y minus 3z equals to 3, 10x minus 3y plus z equals to negative 20, negative x plus 3y plus z equals to 8. So I would like to use the elimination method. So for elimination method, I see that this is a negative 5, this is a positive 10. I am going to multiply both sides of the first equation by 2 and then add that to the second equation. So 2 times negative 5 is negative 10. When you put negative 10 plus a 10, negative 10 plus 10, then you can cancel x immediately. So the language that I use here is, so okay, I'm going to take 2, multiply the first equation, okay, on both sides, and then subtract, and sorry, not subtract, and then add that to equation 2. So this is 2. Let's state this. So multiply 2 on both sides. So multiply both sides of equation 1 by 2. All right, let's do it. Remember, you are multiplying every single coefficient by 2. So 2 times negative 5, negative 10. 2 times 2, 4. 2 times negative 3, negative 6. Also, 2 times 3 is equals to 6. Equation 2, no change, so 10x minus 3y plus z equals to negative 20. So when I add them, the x will be cancelled, right? Negative 10 plus 10 is gone, and then positive 4 plus negative 3, 4 minus 3 is 1, negative 6 plus 1 is negative 5. Equals to negative 14. I cannot solve this equation yet because this is one equation with two unknowns. So that means I am going to see what I can do for equation 2 and equation 3. So this is a 10. I would like to multiply 10 on both sides. All right. So we are going to take equation 2 and then we are going to add that to take 10, multiply equation 3. So equation 2, no change. 10x minus 3y plus z equals to negative 20. And then we take 10 times equation 3. So 10 times negative x, negative 10x. 10 times 3y, positive 30y. 10 times z, positive 10z. And then 10 times 8 is 80. So what I just did is I take 10, multiply each coefficient, and then take 10, multiply the other side. And then 10 plus negative 10 is gone, so I am going to add them. 10 plus negative 10, x is cancelled. Negative 3 plus 30 is 27y. And then z plus 1z plus 10z, that is 11z. Negative 20 plus 80, that is equals to 60. All right, so now I have two equations. So what I am going to do next is, hold on, so let me take a look right here. Do you see that the first equation right there? So I have y equals minus 5z equals to negative 14. I can put this as y equals to negative 14 plus 5z. Okay, and then I am going to plug in this y into this y. So I want to remind you one thing. When you do system of linear equations, there is always more than one way to solve it. Okay, there is no cookbook recipe. This is very unpredictable, this type of problem. All right, it can be very difficult, but to be able to do it on a test, because you have a very short amount of time on a test, you have to do some practice, you have to earn experience. All right, okay, so what is next? The next step is we have 27 times negative 14 plus 5z and then plus 11z equals to 60. All right, so let's do a distribution. I have negative 378 plus 135z plus 11z equals to 60. 135 plus 11 is 146. And then 60 plus 378, that is 438. That gives you a very nice number. So z is equals to 438 divided by 146, that is equals to 3. So now I have z is equals to 3. Okay, what else can I do? When z is equals to 3, I can plug it into that equation. So I will be using this again. I have y equals to negative 14 plus 5 times 3, not z, times 3. So 15 minus 14, y is equals to 1. You see how easy it is? As long as you get one of the variable, everybody will just pop up immediately. Okay, now let's move on to the final step. So the very final step, I'm going to switch to a different color because now I have z equals to 3 and then y is equals to 1. Okay, let's plug it into the first equation, third equation. Okay, so we have negative x plus 3 times 1 plus z plus 3 is equals to 8. So we have negative x plus 3 plus 3 is 6 equals to 8. Negative x is equals to 8 minus 6. Negative x is equals to negative positive 2. So we have x equals to negative 2. So what that means is each equation represents a plane, just like a piece of paper in a three-dimensional space. That means you are holding up a paper in the air. You have three pieces of paper. They meet at one point, and that point is x, y, and z. The exact location is x equals to negative 2, y is equals to 1, and z is equals to 3. And then that is the end of this problem. All right, so we have much more system of linear equation in the upcoming video, and I will meet you there.